Okay, so now we turn our attention to transforming data. So far we talked about looking for mistakes or corrections to make and missing values to impute and so on and so forth. From this point onwards, we're going to do some transformation. These are the four kinds of transformations that we're going to discuss. Binning. Okay. There are data analytic models that require, like for example, Bayesian analysis, which we'll be covering in our next course in spring. Bayesian analysis requires categorical data. So if you have a continuous variable with lots and lots of values, Bayesian analysis becomes really not very good. It becomes very computationally ineffective. So we have to bin them, okay? Especially things like age. Age can be, you can bin them toddlers and early teenagers and young adults and so on. So that's what is called binning. Okay? So you can bin, and then dummy variables is when you have a categorical variable, okay, which cannot be used in numerical models. There are regression models and neural networks. Okay, they require numeric columns. So how do you take a categorical column and convert it into a numeric column? Okay, so that is what dummy variables is about. Normalizing is about, there are again data analytic models that measure distances. So if you have variables that are really large, okay, let's take two examples. Okay, like age. Age is what? Usually somewhere between, if you're talking about adults, you're talking about like from anywhere between 20 to say 80 or 90 years, right? So it's going to be a 2-digit number. And then you take annual income, it's going to be in tens of thousands or even hundreds of thousands. Okay. So these two are magnitude-wise so different. So when you use these two variables together in a distance calculation, the variable with larger magnitude will have larger distances, and they will then have an undue or oversized influence on the model than the variable with small values. Okay, so to level the playing field, we want to convert all the values into the same range of values, and that's what normalizing means. Normalizing, there are 2-3 different ways in which you can normalize. So we look at two of them, and those are the most commonly used normalizing technique. And then power transformations. So sometimes you want, if you want to fit a nonlinear, suppose if you think of it in 2 dimensions, if you have a curved function or relationship, okay, so you want a nonlinear function to apply to the data. So then you need power transformation like square or square root or logarithm and things like that. And we've already seen that in NumPy. So that's what pretty easy to do using NumPy function. So these are the transformations that we're going to look at. So let's start with discretization, or otherwise called binning. And there are two of them. There is pd.cut, okay, where you specify in pd.cut, you specify what the intervals are. Okay, there are several ways to specify that. So like minus 10 to 0, 0 to 20, 20 to 4, or whatever. Okay, so that's one way of doing it. pd.qcut is saying that I want 10% of the values in the first group, 15% in the second group, and things like that. So cutting the values not by the value of the range, but the number of observations that will fall into each group. So that will be qcut. Qcut, the Q stands for quartile. So how many quartiles you want to cut the values into. Okay. Values of numerical variables are put into bins, binned objects. Okay, so what results, what you come back out from the pd.cut, pd.qcut, is a categorical variable. So the categories will be the bins, okay, bin number 1, bin number 2, bin number 3, and so on. Okay. So it is a categorical variable that you get back from PD.cut or PD.qcut. So we're going to look at TF3. So here these are the, and remember, you do binning only for numeric variables, because the whole purpose of binning is to take a numeric variable and make that into a categorical variable. Okay. So here you do a describe. Describe gives you basic information about what is the maximum value, what is the minimum value. So it gives you where the cuts are supposed to know, what should be included in the cut. Okay. Binning with PD.cut. Of course, PD here what stands? PD is the nickname for pandas. Okay. Set up bin limits starting from the smallest limit. By default, left side is non-inclusive, so you have a parenthesis, and the right side is inclusive, so you get a square bracket. And you can change that if you want to change it. Okay, by default, left side is non-inclusive. Okay, to override the default, you use right equal to false. If you say right equal to false, then right will be non-inclusive, left will be inclusive. Okay. And then you can use labels. You can give, otherwise the range will be the labels for each bin. Each bin will be known by this parenthesis and square bracket label. Okay. Instead, you can give descriptive labels using the list option. So here is a list bin for V1. So V1, we have minimum is minus 1.67, maximum is 8.26. So we start with minus 2. So it is smaller than the min. So minimum value will get included. Okay, you want to make sure that everything is included, right? So, and then you specify the cut locations. Okay, and you make sure that the last cut location is the last cut location, this will be the lower limit. So the upper limit will get included, whatever it may be. Okay. All right. So that is your bin list, and then you take the variable and apply the bin list. So now your 12 observations or, well, okay, actually this is that's the right limit. Sorry, I misspoke. Okay, that's the reason why you get a missing value for 11. So these are the categories that we get: -2 to -1, left non-inclusive, right inclusive, and then -1 to 0, 0 to 1, 1 to 2, 2 to 3. Okay, so then each value gets converted into one of these labels, and 11th value is 8.26, for which there is no bin, so you end up with NaN. Okay. All right, now you can use the same bin, okay, and then if you use the dot codes property, then instead of these labels, the code will be assigned, okay, like 0, 1, 2, 3, and so on. So you'll get codes like that. Okay, instead of these bin labels, which are kind of clumsy, right? -2 to 1, -1 to 0, and instead it will be codes. But codes also is not very useful because you end up with 0, 1, 2, 3, and we don't know what 0 is, we don't know what 1 is. So in fact, instead of codes, the clumsy labels themselves are more descriptive because you know exactly what the bin is supposed to be, whereas codes, you don't know what they are. But you can specify labels instead. Okay, in the cut, so this was the original two things that we gave in the cut function, right? Then you can say labels, and then you can give your own labels, which, in this particular case, our own labels is not very different from the labels that is generated by default. But sometimes, you may be able to give better labels. If you're able to do that, then this is a useful option for you. So, so you get the bins will be the labels that you have assigned. And one more time, check it out, that what you get back is a categories column. This is the data type is category. Okay. And you can put it back in, suppose if you say df3 and then v1 bin, for example. Okay, so if you want to save, right now it's not saved anywhere, right? You just bins and then it's gone. So if you say df3, give a new name, like that, okay, and then you print df3, then you see that the new column is inserted, and instead of the value, so you get the bin label, and it is a category column. Now, if you use right equal to false, of course the right side is going to be non-inclusive, left side will be inclusive. Okay, equal. Suppose if you want equal width bins, okay, you don't care about what the cutoff points are, you just want them to be equal width, then you can specify number of bins you want, and the precision is the rounding precision. So it just creates 4 bins. Now you see that 11 is no longer a missing value because you have not, you just specified how many bins you want. So it's going to take the entire range and cut them into 4 equal sized bins. So every value will have a bin to go to. So there will be no missing values. Okay?